Welcome to Module 9, Temperature, Humidity, Coil, and Freeze Protection. In this module, we coordinate supply air temperature, cooling, heating, humidification, dehumidification, reheat, coil capacity, and layered freeze protection. The professional goal is not only comfort, it is controlled temperature and moisture, verified coil performance, and protective behavior that prevents serious equipment damage. The objectives in this module are practical. Learners should be able to coordinate supply air temperature reset, cooling, heating, humidification, dehumidification, and reheat. They should verify airflow, plant availability, sensors, valves, and coil capacity before changing control settings. They should also separate normal low-limit control from serious freeze trip protection and use trends to diagnose capacity, flow, and sensor problems. The core concept is that temperature control is not just a PID loop. The coil must have airflow. The plant must provide heating or cooling, sensors must be valid, and protective limits must remain active. Normal control prevents routine excursions. Independent protection limits the consequence when normal control fails. A comfort loop is not a replacement for freeze protection. Supply air temperature strategy must define the normal set point range, reset input, reset rate, cooling and heating order of action, economizer interaction, dehumidification override, high and low limits, and sensor failure fallback. Reset should be slower than the local temperature loop and should use representative, validated demand signals. Energy savings are not success if the reset defeats humidity control or protection. Cooling coil control should be enabled only when airflow is proven, cooling is available, the discharge or supply air sensor is valid, the active mode allows cooling, and protective limits are normal. If the cooling output reaches 100% and temperature remains high, do not keep integrating blindly. That is a saturation condition. Check water temperature, flow, coil condition, airflow, sensor accuracy, valve movement, and capacity before assuming the PID needs tuning. Heating coil control may serve warm-up, low-limit control, occupied heating, or reheat. The sequence must avoid overlapping purposes that cause simultaneous heating and cooling. A valve opening does not create useful heat if the pump is off, water temperature is low, flow is unavailable, or the coil is not transferring heat. For steam coils, condensate removal, trap condition, and valve characteristics also affect control. Humidity control must consider psychrometrics. Relative humidity changes with temperature even when moisture content has not changed. Dehumidification usually requires cooling air below the dew point and may require reheat to avoid overcooling. Humidification requires airflow proof, an appropriate high-limit sensor, and protection against condensation. Treat humidity as a moisture problem, not simply a second temperature loop. A dehumidification mode day should be intentional. Verify the humidity sensor and airflow, enter the mode after a persistence delay, lower the supply air set point gradually within approved limits, use cooling to remove moisture, and use reheat only as required to prevent zone overcooling. The mode should be visible to operators and should exit with hysteresis after humidity recovers. Freeze protection should be layered. It begins with adequate heating water temperature and circulation, continues through normal heating valve control and low-limit control, and then includes the low-temperature detector or approved protective device. If a trip occurs, the sequence may close outside air, open the heating valve, stop fans, alarm, latch the trip, and require authorized reset according to the approved design. Repeated freeze trips require root cause review, not bypassing. Normal low-limit control and a freeze trip are different. Low-limit control modulates heating or limits outdoor air to keep the air temperature above a safe target. A freeze trip is a protective action that operates when normal control has failed or unsafe local temperature is detected. Using the trip as routine control creates nuisance shutdowns. Disabling the trip to stop nuisance alarms removes protection. The correct response is to find why normal control cannot maintain safe conditions. Coil diagnosis requires relationships, trend entering and leaving air temperature, entering and leaving water temperature, valve command and feedback, airflow, flow or differential pressure, fan status, plant supply temperature, set points, and active limits. A cooling or heating valve at 100% with little response does not prove the valve failed. It may indicate missing fluid flow, poor fluid temperature, a dirty coil, excessive airflow, sensor error, or capacity above design. A common failure scenario is a preheat coil that freezes while the BAS graphic shows the heating valve at 100%. In the field, the actuator may be moving, but the valve stem may be disconnected, or water flow may be unavailable. If the low temperature detector has been bypassed after nuisance trips, the system loses the independent protection layer. The professional response is to restore protection, verify mechanical movement and coil response, and perform root cause review. The best practices are simple but powerful. Make heating and cooling order of action explicit. Bound supply air reset. Include plant availability and airflow proof. Make dehumidification, humidification, and reheat modes visible. Separate normal low limit control from freeze trip protection. Trend coil response with air side and water side evidence. Latch serious protective trips and document recovery, reset, and root cause review. Let us summarize Module 9. Temperature control depends on airflow, coil capacity, sensors, and plant availability. Humidity control requires psychrometric thinking and visible operating modes. Low-limit control and freeze-trip protection are different functions. Coil diagnosis requires air-side evidence, water-side evidence, command proof, and mode context. Serious protective trips require root cause review, not repeated reset or bypass. Complete the knowledge check before moving to Module 10. Supply fan and duct static pressure control.